All right, so we're gonna look at this problem dealing with motion in one dimension. So here we have a motorist, an expired license tag. So like I assume that's a license, like license. Oh no, license tags. That's license plates, maybe, but it doesn't matter. Who cares? Traveling at 10 meters per second down the street, then a policeman on a motorcycle taking another 5 seconds to finish his donut. So he was eating a donut on the motorcycle. Finished it in 5 seconds, which is pretty good. He then chased this motorist, and it goes off at an acceleration of 2 meters per second squared. All right, so we got to find how long the time required to catch the car. How long did the cop take to catch the guy? And how far did they go? The distance a trooper, or whatever the cop traveled while they were overtaking the motorist. So they were racing something. So we'll use these equations, which are the same as those ones. So I'm going to erase them. I'm going to erase these because I can have some more space to work this problem out. And what the main skill you want to be able to apply in this unit is understanding how these equations work together and how they can help you solve velocity, position, like acceleration, time, all that stuff. And you basically just want to do a lot of practice problems. The more the better. So here we have an equation that gives you velocity explicitly. This one gives you position. And here gives you velocity as well, but it's only velocity and position, well, and acceleration, but this one doesn't have time in it. But in this case, there's always more than one way to do these and solve these problems. Just so you know, that's what I like about physics and math. But I would naturally approach this as thinking of this problem as where or like at what distance are they, like when are they going to be at the same location? Like what is the location? Like how far is that going to be? Like when are they going to be at the same x position? So let's draw a picture. We should always make the lines easier. So here we have, this will be the motorist. This will be the cop. And this line will be when t equals 0. At the start, I guess. Now, at t equals 0, like the cop is, on his motorcycle and he's doing it, and he just, he needs to finish his donut, so that's why he doesn't take off right away, because, he probably got like one of those like Jelly Filled or really like deluxe special donuts and they want to throw it away. So then let's this coordinate in terms, we'll have these coordinates be like 0 or not, well, t comma x. You don't really need, but just kind of make it have some sort of like organization. So t is 0 here, t is 0 here, and so is x. Now it says at 5 seconds, or in 5 seconds, how far would this guy have gone if he's going 10 meters per second? So it's just going to be 5 times 10 because he's going 10 meters per second. He's not accelerating. So then it'll just be that when t equals 5, his position will be 50. So let's have this be like when t equals 5. Oh, actually, duh. This is why I shouldn't even put that. So the basically the guy has 50-meter head start over the cop, because the cop is at like the same position at 5 seconds. He's not like he didn't get anywhere. He's still like at 0, or he's still at 5-0. But again, in this case, it probably wouldn't be helpful using this graph as in terms of like looking at t and x, because they have to be different axes. So maybe I probably shouldn't have even drawn that. But what you want to essentially know is that the guy has a 50-meter head start. So like the motorist's position, let's use this. Let's use x m. It's like x motorist. This will be the motorist. His position is going to be 50 for the initial position, plus his velocity, which is 10 meters per second. So plus 10t. This will tell you his position at any time t. For the cop, it's just write x to the cop. His position will be, he doesn't get that 50-meter head start because he stayed at 0. And he doesn't have an initial velocity because he's at a dead stop. But he's got an acceleration because he's accelerating at 2 meters per second squared. So his will be 1/2 times 2t squared. And this is just going to be t squared. So you want to basically just see when are these going to be the same. Because when these are going to be the same, that means they are going to be side by side, I guess, so to speak, and they're chasing each other. So we just said 50 plus t, or 50 plus 10t. $50 plus 10t is equal to t squared. No. Our quadratic equation is on our hands, so let's see how this is. So we get some math going on. Let's bring this stuff to the right. So we have 0 is equal to t squared minus 10t minus 50. How is that so cool? Just want to have to minus 50t minus 10t minus 50. So let's remember the quadratic formula. Let's move over here. In this case, we're talking about solving for t. So t negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is for an equation you will usually learn as like y equals ax squared plus bx plus c. But let's just write it as t equals ax squared bx plus c. This is typically what you'll learn in your algebra 2 or geometry class, whatever they call it nowadays. So then we just solve this with this. So like the a here is going to be the coefficient of t squared, which is 1. The b is going to be the negative 10 because that's the coefficient of t. And the negative 50 is going to be c. That's your constant. Then we just got plug and chug. Let's plug it in. I'm going to go over here. Plug this and plug these values into there. That's a nice one to stick with that. T is equal to negative b, which means 10 plus or minus the square root of b squared. B squared will be 100. Negative 10 squared will be 100. Let me just write it down like this. So just that and use no detail. Minus 4 times a times c. All over 2a. So all over 2 times 1 or 2. Now that this will be 10 plus or minus 100, 200 is the square root of 300. All over 2. Square root of 300, I think, is like 20. Oh no, 17. Yeah, I guess that makes sense. So we have t is equal to 10 plus or minus 17.32-ish all over 2. Now, if we were to minus 17.32 from 10, it will give us a negative number. And we're not dealing with negative time yet. That's, it's like in the future once we know how to time travel and stuff. So we're only going to use the one where we have 10 plus 17.32. And I'm going to go back over here because it works out. Some things. T equals 10 plus, we'll do 10 plus 17.32, which is 27.32 over 2. And that'll give you 13.66. Yeah, 13.66. All right. So it's going to take the cop about 13.66 seconds, a little under 14 seconds to catch the guy. I assume the guy will stop. He has to keep on going after him like Fast and Furious or whatnot, but 13.66 seconds to line up with him. And then how far do they go? We just got to plug that t into our like position or distance equation. So this guy. So let's plug the we just got to plug the 13.66 into well, you can plug it in this. No, yeah, we'll plug it in this one. That's probably the easiest. We can plug it into either the cops, either the cops equation or the motorist. Doesn't actually matter. You're gonna get the same thing. So let's say we did 13.66 squared. Fumbling my markers. So I say I use this guy. I'd have 13.66 squared. That would give me like about 187, 186.6. If I did the motorist, it'd be 50 plus 10 times 13.66. I should get the same thing. Let's just make sure that I don't know if this is the one time I make a mistake. 50 plus 10 times 13.66. 186.6, so we're good. Matches up. Most likely doing this stuff right so far. All right, so I hope that helps. But again, make sure you practice. And I'll see you guys in the next problem.